Okay, so good afternoon, everyone. So this time we'll tackle about the basic calculus topics, which focusing on problems on derivatives and optimization problems. Okay, so let us have first the basic concept of derivatives. So let f of x is equal to x to the power of n. Suppose that we have this type of function or polynomial function. So to get its derivative, we have here f prime of x is equal to n times x to the power of n minus 1. So what is the concept is being described in this given function is that we will just multiply the exponent to its base, then subtracting 1 or by 1 from the exponent. So that's why we have here n minus 1. Then another one, derivative of c, or c is referring to any constant, or derivative of the constant is equal to 0. So any constant, its derivative is 0. So we have here an illustrative example. Find the derivative of f of x is equal to x squared minus 2x plus 6. So we can now apply the first concept, basic concept of derivative. Okay, so we can have f prime of x is equal to 2x to the power of 2 minus 1. We multiply the exponent, which is 2, to the base, which is x. So we have 2x to the power of 2. Then subtracting 1 from 2 from the exponent, so we have 2 minus 1. Then minus 2 plus 0, because 6, the derivative is 0. Then finally, we have here our final answer for the derivative of this function f of x is equal to x squared minus 2x plus 6 is equal to, we have here 2x minus 2. Okay, we have here the following sample problems. Number 1, so we have 4 sample problems. Find the derivative of y is equal to square root of 15 x squared minus 6x plus 2. Second, find the derivative of y is equal to e to the power of 2 cos 2x. Third, the sum of two positive numbers. This one is actually under optimization problem for this number 3 and 4. The sum of two positive numbers is 12. What are these numbers if their product is a maximum? So we don't know this maximum, so therefore we have to use the concept of the optimization rule. Number 4, a rectangular garden is to be fenced off along the side of the building. So it means that no fence required along the side. There are 120 meters of fencing materials to be used. Find the dimensions of the garden with the largest area. So we are asked to identify in the last problem the largest area, no, the maximum area. Provided that we are only given 120 meters of fencing materials. So let us have here the solution for number 1. Find the derivative of y is equal to square root of 15x squared minus 6x plus 2. Then first that we're going to do for this type of function, this is actually, we have here radical function, no? Rewrite the function in the form of y is equal to, so from that, square root of 15x squared minus 6x plus 2, we can rewrite that one into rational form, no, rational exponent. Y is equal to the quantity of 15x squared minus 6x plus 2 raised to the power of 1 half, because that one is the index of what kanang symbol ng square root. So we have 1 half. Then we can now get the derivative. So we have y prime is equal to 1 half, because we actually apply the first concept, no? The first basic concept of derivative. We multiplied 1 half, then we will have to copy. This one is we will actually use the chain rule of derivative, meaning we have to derive the exponent at the same time we will also going to derive the function inside. Okay, so we will bring down or multiply 1 half to the base, so we have 1 half times the original function inside. We have 15x squared minus 6x plus 2 raised to the power of 1 half minus 1. That is actually from the concept presented in the basic concept, times derivative of the function inside, which is 15x squared minus 6x plus 2. So we still have to get the derivative of the function inside. Okay, after that By simplifying, we can now have 1 half times the quantity of 15x squared minus 6x plus 2 raised to the power of negative 1 half, because 1 half minus 1 is 1 half, negative 1 half. Then the derivative of 15x squared is 30x minus 6 plus 0. Then simplifying, we get y prime is equal to 1 half times 15x squared minus 6x plus 2 raised to the power of negative 1 half times 30x minus 6. Then we will also use the power rule. No, this is actually coming from algebra. So if we have a to the power of negative n, that is actually equivalent to 1 over a raised to the power of n. So the n now, or the exponent, become positive using this rule. Okay? So we can apply that one by rewriting the quantity raised to the power of negative 1 half above. No? So from that, that is actually equivalent to y prime is equal to 1 over, we have 2 times the quantity of 15x squared minus 6x plus 2 raised to the power of 1 half. So from negative, that will become positive. Multiplied by the derivative of the function inside, which is 30x minus 6. Then simplifying, we get 30x minus 6 over 2 times this, the quantity of 15x squared minus 6x plus 2 raised to the power of 1 half. Then we know that we have here 30x minus 6 from numerator, that they are actually divisible by 2. So we can reduce them or divide them by 2 because we have 2 from the denominator also. So we have 15x, 30x divided 2 is 15, then negative 6 divided 2 is negative 3. So that's why we have negative 50, no, we have positive 15x minus 3 over the function from the denominator. We have 15x squared minus 6x plus 2 to the power of 1 half. Finally, we have here the derivative of the function y is 15x minus 3 over the square root of 15x squared minus 6x plus 2. So we just rewrite from the rational exponent to the radical function, no? Or radical form. 15 square root of 15x squared minus 6x plus 2. Okay, let us now proceed to solution for number 2. Find the derivative of y is equal to e raised to the power of 2 cos 2x. So this one, I know that mostly the students would really feel difficulties, particularly when answering this type of problem, no? Especially when it involves Euler number, no? E to the power of 2 cos x, 2 cos 2x. So the concept, so we will have to use e raised to the power of u du. That's the concept that we're going to have. No? So we let u be equal to 2 cos 2x. So we actually use some variable because we are still going to have or to get the derivative of the function from the exponent. So we can now get the derivative of u. We write down du is equal to 2 times the derivative, of course, sa cosine is negative sine. Then just copy the angle, which is 2x. So we have negative sine 2x times derivative of each angle, because we still have to use the chain rule of derivative. So we multiply it. We have here 2x now as its angle. So we still have to get its derivative. Next, we have here du now is equal to 2 times negative sine 2x is negative 2 sine 2x times derivative of 2x, which is 2. Then finally, we have here q is equal to negative 4 sine 2x. So we can now have y. From that, y is equal to e to the power of 2 cos 2x become y prime. As we get its derivative, y prime is equal to e to the power of u times du. So we have here the du value is negative 4 sine 2x. So we can now have y prime is equal to negative e to the power of u times negative 4 sine 2x. Then finally, we have here y prime is equal to negative 4e 2 cos 2x sine 2x, because we know that the value of u is 2 cos 2x. So we have to rewrite again the corresponding value of u, which is 2 cos 2x. Okay. Then let us have also here the solution for number 3. This one is for optimization problem. The sum of two positive numbers is 12. What are these numbers if their product is maximum? So this time, we are going now to have some steps for solving this type of problem under optimization. So we let x and y be the numbers, or we let x be the first number and y be the second number. Then we know from the given scenario that the sum of these two numbers is 12. So we have x plus y is equal to 12. And we let p that denote their maximum product, meaning then therefore p that is equal to x, y. So the maximum product between x and y. Then we can also rewrite from the function x plus y is equal to 12. We can actually simplify that into y is equal to 12 minus x. So we transpose x to the other side so that we can figure out the value of the other variable, which is y. Then from that, because we have p is equal to xy, we can now have p is equal to x times y, then replacing the value of y, which is 12 minus x, to become x times 12 minus x. Then simplifying, we get 12 times x is 12x. Then x times negative x is negative x squared. Okay? At this time, we can now get the derivative of p. No? So to get the derivative of p, so we have 12 minus 2x. No? Then after that, we can then let p prime be equal to 0. So that 12 minus 2x is equal to 0. Then we have negative 2x is equal to negative 12. We transpose positive 12 to the other side to become negative 12. Then divided both sides by negative 2, we get x is equal to positive 6. So we already have the value of the first number, first variable x, which is 6. We can now identify the second value of the other variable, which is y. Y now is equal to 12 minus x. So therefore, y is equal to 12 minus 6 is equal to 6. Therefore, they are actually equal, no? Equal ang ilang value. So therefore, the two numbers are 6 and 6. Wherein their sum is 12 and their product is a maximum. So this is the biggest the product between these numbers, no? Wherein their sum is 12. Okay, let us have here another example. Number 4, a rectangular garden is to be fenced off along the side of the building. So fence off, both pasabot, we are not going to, or no fence required along the side of the building. There are 120 meters of fencing materials to be used. Find the dimensions of the garden with the largest area. So what we are going to identify is to maximize the area, provided that the fencing materials that we're going to use is only 120 meters. So we can now recall the formula for the perimeter. Perimeter is equal to 2x plus 2y if all sides is being required, especially when talking fencing, if you're going to fence this given rectangular, But for this time, it is being described that one of the side of this building will be fenced off, So let x and y be the length and the width of the rectangular garden. Okay? Then the perimeter, we have p now is equal to 2x plus y. The other one, 2x, and the other one is y, because along the side of y, okay, that is the side of the building. So therefore, it is only one side, of the building along with y, is being fenced. Okay? So therefore, p is equal to 2x plus y. Then therefore, to maximize the area, we have area is equal to x times y. And p is equal to 120. So we have 120 is equal to 2x plus y. Then we can now get the value of y, which is 120 minus 2x. Then we have here, area is equal to xy man ang area, Formula niya is area is equal to x times y, or length times width. So we have 120 or x times 120 minus 2x because the value of y is 120 minus 2x. Then simplifying, we get area now is equal to 120x minus 2x squared because x times 120 is 120x. Then x times negative 2x, negative 2x squared. Then, after that, we can now get the derivative of a. So we have a prime is equal to 120 minus the derivative of negative 2x squared is negative 4x. Then we can also let a prime be equal to 0 so that we can identify the value of x. So we can now have 120 minus 4x is equal to 0. Then negative 4x now is equal to negative 120. Then dividing both sides by negative 4, x now is equal to 30. So we already identify that one of the side of this rectangle is 30. So let us now identify the other side. Okay, using this formula or form, y is equal to 120 minus 2x as being described in the as we simplified that one in the previous steps, no? So we have here y is equal to 120 minus 2, replacing the value of x which is 30, so we have 2 times 30. So 120 minus 2 times 30 which is 60, 120 minus 60 is we have 60. Therefore, the dimension of or dimensions of the rectangular garden is 30 meters by 60 meters. So I hope that those example will help you, especially when you're going to answer some of the problems on derivative and optimization problem.